Alright, so here's a demo of the TinyPLL. I have hooked it up here. It is supplied over USB 5 volts from my computer, and it takes the reference signal from a signal generator 10 MHz 0 dBm, and the LED lights up, meaning that it detects a reference. Steady LED light means reference detected. Okay, as an VCXO, I am actually using another signal generator, and I have configured the TinyPLL to lock at 106.5 MHz. And this signal generator, I am using the external FM modulation input in DC mode to simulate a tunable crystal oscillator. And I am also monitoring the voltage going out. It's tune voltage, and you can see here that it is 2.6 volts, which is in the middle of the scale. And this is because there is no signal out from the signal generator. The carrier is off. When I turn it on, RF on, 3 dBm, I guess I can 0 dBm. I have to tune it a little bit downwards because of the modulation. It's designed to get an external voltage. 0 volt in is the exact carrier frequency, and I cannot go on negative voltages with TinyPLL, so I had to offset it a bit. But in this case, 106,491 and 5 kilohertz per volt. So we can see here on the scope that it reached lock state, 3.1 volt. I should say also that this instrument, it's 600 ohm impedance, so I put a simple NPN transistor voltage follower here to be able to lock. Without that, it will just pull the voltage to 0 because the output impedance is so very high from the loop filter. So now we have a locked state, and if I adjust the center frequency a bit, you should see on the scope that it adjusts the voltage. I can, like this, so it goes up and down again to reach. You can see I'm going in steps, 1 kilohertz, and now I've reached 106.5, and it can achieve lock by 0 volt. It is showing for 50 millivolts, but then there is the meter follower, so it's actually producing 0 volt. But if I go to a higher frequency, higher carrier frequency, 106,501, it can no longer produce a lock because it cannot reach a negative voltage, which the signal generator would need to lock. So we can see here that it's going up and down, and it cannot lock. And if I increase the frequency further, we can see that the rate of this bouncing up and down, it will be faster and faster, until eventually it is so high that it will just stay in the middle of the, more or less in the middle. If I increase even further, now I am 40 kilohertz away, then it's just a flat line in the middle, because it has gone out of the pull-in range. The loop filter is too narrow. And if I go back again, 106,489, and it locks. 3.7 volt going into the FM modulator, 5 kilohertz per volt, to lock at 106,489. Or actually so it pulls the frequency to 106.5 megahertz. Yeah, so this was a demo of the operation of TinyPLL.